Welcome back. This is Chemistry 2, Unit 4, Lesson 1 on rates of reaction. And we are on video number 4. So we're going to look at how we do the problems for rate of reaction. So we're given an equation, A plus 2B yields 3C plus 2D. And we are given information on A. So at time 0, when we start the reaction, A is this molarity. 125 seconds later, it has decreased to this. So our first question asks, what is the average rate of reaction? So we have to use our general rate of reaction formula, which I am going to derive. So we take that from the coefficients up here in this reaction. So the rate is equal to negative 1 over 1 because A has a coefficient of 1 times the change in concentration of A over the change in time. That could also be equal to, well, we have a coefficient of 2 in front of B, so negative 1 over 2 times the change in concentration of B over time. The coefficient in front of C is 3, so it's positive 1/3 times the change in concentration of C over time, or 1/2 the change in concentration of D over time. So if I forgot to mention, brackets around something stands for molarity. So if we're given information on A, we can find the average rate. This is the average rate given this part of the reaction. So it's equal to this. So all I have to do is put in, for number 1, rate is equal to negative 1 over 1 times the change in concentration of A would be A2 minus A1. So 0.4242 minus 0.4658 all over the change in time. And when you calculate this out, because we have the negative here, because what's in the parentheses is going to give us a negative value. So negative 1 times what is in the parentheses gives us 3.33 times 10 to the negative 4th moles over seconds. Molarity or molar per second. So molarity would be the units here, seconds, the units here, or you could have ms negative 1. Either one works for me. Now, that rate there is equal to each part here. So if it's asking for number 2, what is the rate of disappearance of B? What we're solving for is what is inside the parentheses. We know what the average rate is. All we have to do is say, okay, inside of here is the rate of disappearance. Inside of here for C is the rate of formation of C. This inside of the parentheses is the rate of formation of B or D. So all we have to do is say, okay, I'm going to find or let this equal to X inside of here. And the average rate, 3.33 times 10 to the negative 4th ms negative 1 is equal to negative 1/2 times the rate of B. And that is the disappearance of B. So that's what I'm solving for. So I just have to take this and multiply it by negative 2 each side, and I get negative 6.66 times 10 to the negative 4th ms negative 1. That is my answer. So once you determine what the average rate is, it's easy to find what these are. So let's look at number 3. What is the rate of formation of C in molar per second and molar per minute? So I know what the average rate is, and I have this equation here. So the average rate is equal to 1/3 the rate of formation of C. So 3.33 times 10 to the negative 4th ms negative 1 is equal to 1/3 times the rate of c. So all I have to do to solve for the rate of c is multiply both sides by 3. And I get 9.99 times 10 to the negative 4th ms negative 1. There's my answer in molar per second. So now I have to convert this into molar per minute. So with this is just a simple conversion, but you have to be careful because that is what molar per second. That's how many moles per liter are changing per second. So if I want to convert that, I know that there are 60 seconds in 1 minute. I set it up like that so our seconds cross off. So I have to take 9.99 times 10 to the negative 4th times 60 to give me 5.99 times 10 to the negative 2nd molar per minute. Everybody usually makes a mistake and divides by 60, but you have to multiply by 60. So there are 2 worksheets that I'd like you to work on. One, please complete the first one before moving on to the second one. Make sure that you understand if you are given information for something like C and you're not given a beginning time, remember at time 0, we don't have any products. So if you're given information and you're only given this top or this bottom line here, and this would be for a product, you can assume that at 0 seconds, you do not have any products. It would be 0, 0 would be the first set of information. So if all I gave you was 125 seconds and this was a concentration of C or D, you know that at 0 seconds, you don't have any of this product. So you will see that on the worksheets.